We're back. We're back to talk now instead of about neglecting the denominator entirely, using the wrong one. So choosing the right denominator can be deceptively difficult, and you always want to ask yourself if you have the right or maybe the wrong one. So when you're trying to choose your denominator, ask yourself, what question is this statistic that I'm building answering? And is it the one I should be answering? And also make sure that your denominator matches your numerator. And I'll talk more about what I mean by that in a bit. The other question that I really like to ask myself, and thank you to my friend Mark Simon at Sports Info Solutions for teaching me this one. What story is this denominator or this statistic telling? And is it the one I should be telling? So instead of thinking of yourself as someone who asks and answers questions, think about yourself as a storyteller with data. And you have an audience, and you want to make sure that you're communicating the right story, not a wrong or misleading one. Speaking of, let's talk about COVID-19 death rates in the US. And let's go to an interview here between President Donald Trump and Jonathan Swan, a journalist with Axios. I think that's a really instructive exchange because President Trump and the journalist Jonathan Swan, they're using two different measures of death rate. And that leads them to talk a little bit past each other, and they're trying to tell different stories. Trump is trying to tell the story of what epidemiologists would call the case fatality rate, which is the number of deaths divided by the total number of cases. In this measure, the US actually looks like they're doing okay. But what Axios and Jonathan Swan are talking about is the COVID-19 mortality rate, deaths divided by population. By that statistic, the US is doing horribly. Okay, so if you're a case in the US, you actually have a decent chance of surviving. And that could be for a couple of reasons that I'm going to ask you to think about in a moment. But if you're an American, your chance of dying from the virus is much higher than it is in another area. So when somebody says something like death rate or just gives you any statistic, understanding the specific definition behind that is critical. What's the numerator? And really importantly, what's the denominator? People can easily bullshit you if they don't specify what they mean by a term or tell you exactly how they're calculating it, including their denominator. So make sure that you are always clear about that, and make sure that you make anyone else communicate to you exactly what they mean as well. That will make it so much harder for people to pull the wool over your eyes and bullshit you. Really, this one simple trick will help you out in a lot of cases, to use a clickbait term. So which of these statistics tells the more important story, in your opinion? Trump talking about the case fatality rate, or Swan talking about the COVID-19 mortality rate? Here's another spot where I'd like you to pause the video, go to the comment that I've placed here, and respond, written. Don't read your other classmates' responses yet. Just write something, okay? Doesn't have to be long, but take a few seconds and do that now. Okay, moving on to our next example, the COVID-19 case rate in the NFL. So in the NFL in 2020, all players and staff are tested daily for the virus that causes COVID-19. And sports leagues themselves and the media are really struggling with how to report the results. And there are two common ways that you'll see them reported. One would be to, for example, take the data that the NFL has provided over here and interpret it using the number of positives divided by the number of tests that have been done. And by this metric, you get one statistic. But if instead you divide the total positive cases divided by the number of people actually in the league being tested, you get a totally different statistic. And they each have different meanings and may be better in different circumstances. So which one of these is better? It's an interesting discussion. But what you want to go back to is ask yourself, what's the question you want to answer? What's the story you want to tell and that you should tell to actually provide useful information to the public as opposed to mislead them? So maybe your question that you want to answer is something like, what is the burden of COVID-19 in the NFL versus the general population? That seems like a good question to ask. So which of these statistics is better for that question? Well, let me walk you through a thought exercise. This is a situation where everybody is already being tested frequently. In the US, it's easy to miss a case. So we often want to look at the test positive percentage because that sort of tells us, are we testing enough? Like what percent of tests come back positive? And that's what this statistic number one here is. That is actually a really useful statistic to help us understand what's going on broadly in the US. But in the NFL, where you're identifying every case because you're testing so frequently, it actually becomes less useful in that context and situation. For example, what if instead of testing daily, I tested everyone 3 times a day? Has the situation materially changed in terms of the number of cases the NFL is suffering? No, right? But look what happens to these stats. The denominator triples in statistic number one, which cuts the statistic by 2/3. Whereas in situation number two, how frequently we test people does not actually alter the statistic. So the first denominator, in my opinion, answers the wrong question for the NFL. It's a useful part of understanding what's going on in the broader US or in a broader country, that test positive percentage. But in a population that's already frequently tested, it's next to useless. I want to know, in this case, how many cases or what percentage of the population is actually getting sick. And in a situation where you're testing frequently, that's something you can measure, as opposed to having to rely on just whatever cases you happen to catch with insufficient testing. Okay, so when the sports media or the league say we did 400,000 tests and only had 99 positives, what that's meant to make you think is that we've only had, 99 bad instances and 399,000 good instances. But really, you had 99 bad instances and about 7,700 good instances. To use the test as your denominator is basically just making a claim or telling a story that you're testing a lot. That's great, but it's not what we really want to know, which is how often are your people getting sick? Because with tests as the denominator, you can blow that up as much as you want by just testing everybody really frequently and driving that fraction very, very low. And that's not what we want to allow these sports leagues to do when they're reporting their data. All right. Another big thing to talk about is matching your denominator to your numerator. So remember our definitions of numerator and denominator? A numerator is a number of things, and a denominator is how many potential things gave rise to the things in the numerator. So you want to make sure that all the things that could be in the numerator are included, but that nothing extra is there in your denominator. And it is really easy to screw this up. And I'm going to show you right now how even the great Nate Silver messes this up from time to time. So Nate does the following. He makes a claim about the rate of COVID-19 on college campuses. And as the numerator, he uses the number of COVID-19 cases at colleges with students on campus who are testing those students. But as his denominator, he uses the total number of college students and staff in the entire country. So can you think about why this is unfair and in what direction? What would a better denominator be? Is our denominator including all the things that could be in the numerator? I think it is accomplishing that because Nate is talking about all college students. And of course, that is going to capture everybody who could be in the numerator, but it's including a bunch who can't. It's making the numerator too big. It's violating our but nothing extra rule because colleges that are not operating in person or testing their students won't be captured in his numerator. Okay, so that's where the problem arises. It makes the denominator too big and makes the rate of COVID-19 on college campuses that he's claiming too small and not valid to compare with the general population and say, hey, colleges are safe or they're not safe. Okay. The denominator is too big because it includes people who couldn't be in the numerator because they're not on campus. And I just talked you through how that would lead the rate on college campuses to be underestimated. And a better denominator, because I always should leave you with solutions, should be something like the number of people on campuses that are open and testing. Count exactly the people who could be in the numerator, no less, but no more. Match your denominator to your numerator. Two other specific instances that I want to talk about. The first is observation selection effects. This is a really interesting one. So colleges often put something like average class size in their advertising brochures. But what does that mean? Again, you want to ask them exactly what they mean here, because this could refer to two possible questions. One is the average class size at the college. Total class enrollments divided by the total number of classes, where one class enrollment equals one student in one class. But another is what your average class size experience as a student will be on average. And this actually requires you to calculate a weighted average class size. So let's look at how these two can differ. Consider a biology department with 20 classes with 20 students each, so serving 400 total students, and 4 classes each with 200 students, serving a total of 800 students. The average class size is you have 20 classes that are 20 and 4 that are 200, and you multiply those together and add them and divide by the total number of classes, and you get 50 students per class from the administration or school's perspective. But from your perspective as a student, the average experienced class size is actually 140. And the key insight to understand here is that more of you are in larger classes. You have a much greater chance of being in one of those 200-person classes than in one of those 20-person classes. So you end up in more bigger classes because that's where the majority of students go. So even if the average size is 50, you actually experience a much larger class size from your perspective because you end up in more big classes than small classes. And this will be the case for essentially anyone, at least within the same major. This is a really counterintuitive finding, like Bergson's bias, but also like Bergson's bias, you're going to start noticing it everywhere. It explains why you always feel like you may wait longer for a bus because you're more likely to arrive during a long delay than a short gap, or why you're always in the slow lane on the highway because that lane is slower because there are more cars there. So there's a greater baseline likelihood you'll be there. One thing I want to note is that this is different from the concept of selection on observables from econometrics. That is what we call the no unmeasured confounding assumption in regression. So don't get these confused. The last thing we want to talk about with using the wrong denominator is how proportions can be misleading when one of the numbers that go into them can be negative. So here's an example of US jobs gained or lost by sector, tradable goods like manufacturing, or non-tradable jobs like government or healthcare or so on and so forth. From 2000 to 2008, the US created or gained 4 million jobs. They gained 7 million in the non-tradable sector and lost 3 million in the tradable and manufacturing sector. So we could say 175% of the jobs gained from 2000 to 2008 were in the non-tradable sector. 7 million of 4 million. Well, that's obviously nonsense, right? I mean, this guy has the right explanation here. So you have to be really careful if somebody tries to present you data in a proportion where one of the numbers that goes into it could be negative. Here's another example. The Romney campaign in 2012 said that women accounted for 92.3% of all jobs lost under Obama. They were trying to do better with the women vote, the Romney campaign was. So their numerator was saying from January 2009 to March 2012, over here along this blue line, women lost 683,000 jobs. That's this gap right here between the blue and the black dashed line. Their denominator was that from January 2009 to March 2012, the US lost 740,000 jobs. That's this gap right here between the green total line and the dashed black line. So they say women represented 92% of job losses. True. But let me give you an interesting thought exercise. What if we just moved our window 1 month forward to February? From February 2009 to March 2012, women lost 484,000 jobs, but the US total only lost 16,000 jobs. So women represented over 3,000% of total job losses. Now you can see that's obviously bullshit, right? There was no question that women experienced a weaker economic recovery than men. Men here are the red line. They lost more jobs than women, but they also gained them back more quickly from 2009 to 2012. Women lost fewer jobs, but gained them back much more slowly. And there's no question that the claim by the Romney campaign is mathematically 100% correct. I can't dispute their math. But it's the right answer to the wrong question. And so some fact checkers rated it true but false, which sounds ridiculous, but Jordan Ellenberg likes, and I actually like as well. It's true mathematically, but it implies something untrue. People use these kinds of statistics all the time. And the main overarching lesson I want you to take here is that formulating the correct question is much harder than any computations you will do. Even when you get into really complex modeling, just making sure you're answering the right question and telling the right story, that's what makes a great data scientist. That's where you're going to earn your pay and do some good in the world. Because the latter, running these models, a calculator can do that. And you're better than a calculator. So what you want to do is go back and ask yourself, what did you really want to know about the recession? And I think the answer is something like, what happened to men versus women in the recession? And for that, you really want to look overall at what happened. And it's pretty clear that men lost more jobs, but also gained them back more quickly. That's a more nuanced answer. It's not as good a soundbite for the Romney campaign, but it would be more honest about what happened and would still be consistent with the fact that women did have a tougher recovery under Obama. All right, I apologize for the length of that video, but we're going to stop it right here. And whenever you come back, we're going to talk about absolute versus relative differences. See you soon.